So don't be so primitive, Dave Liddament. That's actually the title of my name, not an instruction to me. But before we start, let's talk about bugs. Question one, who puts bugs in their code? Maybe not deliberately, but pretty much everyone probably puts bugs in their code. And I was thinking, why do bugs happen? And I drew this Venn diagram, and I showed it to someone, and they agreed with me. I thought, the first thing is, this is what the code should do. It's probably what the code actually does. And where we don't have this crossover, that's obviously where bugs could be. And to finally add into the confusion this is probably what the developer thinks the code does. And the crossover of all three of them is actually quite limited, which is a problem. And to make matters worse, you might be working on some code and then you come back to it a few days, few weeks, few months later, and you've forgotten so much about it that the little bit there where there won't be any bugs is actually quite small. And obviously, if you can't work out what's going on with the code, there's more chance you're introducing bugs into your code. If the code doesn't actually do what it's supposed to do, then there's a chance of some bugs. So basically, it's just that little intersection there where we know is bug-free. Anywhere else could be full of bugs. So we want to try and make sure our code we want the intersection of all those three to be as big as possible and reduce the chance of any bugs. So we need to be, when we're writing code, really, really obvious. That's kind of what I'm saying. So if we're going to have bugs, when is the best time to find a bug? Well, the worst time to find a bug is months into operation. So let's say we've deployed our code and there was some silly little bug where instead of charging people in pounds, we charge them in pence. And that's going to be very bad. So this basically, this red bar is just how bad it is. The red bar is high, is big, because there'll be probably the later it takes to find a bug, probably the longer it takes to work out what actually went wrong, more cost involved in fixing it, and there's also reputational cost as well. So we don't really want to find bugs then. We kind of want to find them a bit earlier. So maybe we want to find them when the feature is first put into use. And again, that's still pretty bad. It's still a big red bar, not as bad as that one. And there, you might lose a bit of reputation. You say, we've got this great new feature, it all comes out, and people go, oh, this doesn't work. And there's still some overhead. Okay, you've got the bug reports, you've got to work out what's going on. Let's go and fix them. So that's still not great. We could try and find the bugs at testing. I mean, after all, that is the point of testing, really, isn't it? But that's still not that great. I mean, okay, a test fails. We've got to work out what's gone wrong. I mean, unit tests is quite a quick cycle to work out, but integration tests and system tests, it takes a bit longer. So that feedback loop from introducing the bug to fixing it, I mean, it's better than these two, but it's still not great. Really, we want to be finding bugs much sooner. So just imagine if, as we're writing the code, we're told we've made a mistake. That'd be great. That'd be good. Or even better still, just actually not put the bugs in the first place. So we don't really want to be operating over here. We want to kind of be putting our bugs down there. Okay. So this talk, we're going to talk about how we can improve the understanding of our code. So there's a lot of crossover in the Venn diagram of those three things. And we're also talking about how we can move bugs from all the way over there and pull them down there, or push the bugs over to here where they are much cheaper and quicker to fix. Pay attention, everyone. I'm going to ask a few questions. Is this code valid? We don't really know. We don't know. Maybe that's valid, maybe that isn't. Is this code valid? Is anyone still awake? No? Right. I'm going to say this code definitely isn't valid because we can see our function process. The first argument requires something which is of type user. And what we're actually passing it is $A, and $A is the number 1, so it's an integer. And we haven't run that code. What we've basically done here is static analysis. We've looked at the code and said there is definitely a bug in this code. There was no way this will run. So if we actually ran this code, when you get to this line here, it will go, no, it's broken. But if you use some good static analysis tools, some real-time static analysis tools like PHPStorm, it can tell you you've made a bug just there. It's highlighting it. It's even telling you what you've done wrong. It's expecting a user, but you've got an int. So if we think about those errors, all those really expensive ones, we've kind of brought them all the way down here. Here we're at the kind of level where we've written the code and we've realized we made a mistake. But PHP Storm is even better than that, and so are all good IDEs. We've written process, and it's telling us that this is a user you need to pass in. So we know at this stage there's no way we can pass in $A. We need to pass in some kind of user object. So what we've done here is type hinting. We've said the user must be of type user. And that's valuable for a couple of reasons. One, any developer reading the code can see that whatever process does, it does it on a user object. And because we've given this extra information, either PHP will fail if we get to that line, or better still, we're using good tools and they'll tell us we've made a mistake. So that's been really, really helpful to us. Because, well, yeah, I mean, this is the same. We pulled the bugs all the way down to here where they're cheaper and quicker to fix. So let's imagine we've got a class called marketing campaign. It does a load of stuff, but one of the methods we're interested in is we're adding an address. And as you can see down here, we're adding an email address. So an email address, well, we could say that's a string. So we'll type hint it as a string. So in PHP 7 onwards, you can now type hint with primitive types. Primitive types are things like strings, integers, booleans, floats, and a few others. So this is better than having nothing at all. If we didn't have that string there and we just left it $address, you could call this method with 15. And let's just imagine what happens here is we're putting all the addresses in, and at some time later in our code, we are trying to send some emails. And it's only here, much later, we realize that we haven't actually got email addresses at all. We've got a number or something that's a string or something like that. And it will fail here, but that's not the point where we introduce the code. So our cost of fixing that bug and finding that bug is higher, especially if there's lots of places where we could be adding addresses in. So we don't really be operating our bugs here. We want our bugs down here or none at all. But anyway, adding the string, that's a good first step. But these are all strings, and only two of those, the blue ones, are actual valid email addresses. And actually that's actually an address as well. That's our office, my office. So this code is clearly wrong. We are trying to add email addresses, but we've actually put in a postal address. But our IDE can't spot the mistake, and maybe nor can we. Now, we could do things here to improve the code. We could explicitly make that add email address, which is something, if I saw this in code review, I'd probably say. But we can be even more explicit than this. We could create an object called email address and use this instead of one of the primitive types. So email address essentially is just a wrapper for a string. We construct it passing in a string, which is an email address, and then we've got one method here, which is get email address. So now if we look back at that code, we've updated a few bits. Now our add address method, instead of taking a string, it takes an email address object. And we do whatever we do, however we get our email address, we create an instance of the email address, and we pass it to the add address. So if we try to do the bug we did last time, this would fail either when you ran this line, or better still, your IDE would tell you that this is a mistake, because you're passing in a string, and it's actually expecting an email address. And people might say, well, that's all very well, but you can still do something like this. But what we're doing here is we're trying to be really, really explicit. You know, if you saw this, if you saw you're creating an object called email address, and you passed in something that wasn't an email address, hopefully alarm bells would ring. Hopefully someone would spot that in code review. So we're trying to be really explicit, and then that kind of, makes all the things like the developer's understanding of the code and what the code actually does. We're trying to make that Venn diagram, the middle of all three of them, the intersection as big as possible. But it's a valid point. Someone could still do this. Can we do any more? So what we could do is when we're constructing, in the constructor for the email address object, we could actually do some validation. We could say, let's check if this email address is valid. And if it isn't, we'll throw an exception. Now, we should never be instantiating these objects with invalid email addresses. Validating user input, that's somewhere else. But we're saying once we've got this, we're saying this is definitely an email address. So it's absolutely fine to throw some exception, because it's better to throw exception here when we introduce the bug than all the way down there when it's going to be expensive to fix. So with this thing, our email address object, we are guaranteed it represents a valid email address, which is a good thing. As I say, we basically pulled the errors that could be introduced all the way from over there right down to here. More so if we're using good tools for the job. If your IDE cannot do this kind of stuff, you really should get an IDE that can. So other example value objects that I've written recently, one is a point object. So that represents a point on the Earth. It's composed of a latitude and longitude. And those are floats. And even them, it's not just any range, and a float can be any number it likes. There are ranges of what is a valid latitude and longitude. The particular project I'm working on now, they can only be within the UK. So I actually do some validation at the start to make sure my latitude and longitude are valid UK things, which is incredibly helpful if you get your latitude and longitude the wrong way round and you waste an afternoon. And if only I put that assertion in right at the start, it would have saved me some time. If you kind of are on the UK, but live on the equator, you can't do that. It's just a perk of being in the UK. And there's other countries that works in too. But anyway, that's this point object. Postcode, that's another thing. Postcode, there's lots of formats of postcode. If I said, BS8 space 1AB, or you saw a postcode that was BS8 1AB, you know that's the same postcode. But there's three main formats of postcodes. But our value object can just represent that, and we'll talk a bit more about postcodes later. But yeah, that's another one. Settlement type. Clearly, I've been doing stuff recently which is all geographical stuff. But settlement type can be one of 6 values. So it's things like cities, towns, villages, and there's a few others. So those could be represented as a string. But if we make it as a value object, we know that constructed value object is only a valid settlement type, whereas a string could be any value we like. Status, that's another thing. How many times have you got status which isn't binary? It might be 3 or 4 things like, this game hasn't started, this game is active, this game is finished, this game is quit. Those are 4 statuses. If we made a value object that represented the game status, we would know that game status is always in a valid state. So not only do we have, these things are called value objects. So not only do we have the benefit of things like validation, once these things are assembled, we know they have to be valid values. We can do things like normalised data. So postcodes, for example, whatever format we get the postcode in, we can store it in one format, and then we can provide extra methods. If you want your postcode a fixed width, then BS1 1AB would be BS1 space base 1AB. If you want it in the kind of the format that most people see it in, it would be BS1 space 1AB. And if you want no spaces, it would just be BS1 1AB. But these are all methods we can just add on to our postcode value object, and you can say, get me in format 1, 2, or 3, whatever format you want. Things like emails, actually they're case insensitive, Dave at PHP Southwest, all capitals, and Dave at PHP Southwest, all lowercase, will go to the same place. Well, php.u, yeah, if it's a valid email address, it will go to the right place. So we can take that data and just store it in a fixed format and make that available. Other things you can do is you could add an equals method. So if you think about our longitude and latitude, our points on the Earth somewhere, we might say for what we're working in, if these points are within 5 meters or 10 meters or whatever it is, we say, well, actually, they're the same point. So even though the latitude and longitude might not be identical, we could write an equals method that looks at it and says, well, we're going to say, we would say, I'm probably in the same place as you guys here, even though some of us are like 5, 6, 10 meters away. So we can add on these extra things. And yeah, sure, you might have these kind of functions anywhere already in your code, but they're probably in like utility classes and stuff like that. We can put them where they belong. So that's kind of some of the benefits. Well, the main benefits are we're just making our code really a lot more explicit. We're putting in extra validation as well, so people are less likely to make mistakes, or when they do make mistakes, you get the exception at the point you've introduced the mistake, not sometime later. So that's a very quick introduction to value objects and the advantages over using them in some circumstances over, say, primitive types. Any questions? Great. Cool, right. Oh, yes. Oh, it's going to be a difficult one, isn't it? Yeah.
Working with legacy code,
yeah.
Legacy database, you've got data in there that isn't valid. Can you still add the validation? Because otherwise, we found when we pulse it out of the database, it mostly works, and you get a legacy row, and all the validation blows up trying to retrieve what has been for a long time.
Well, what are you doing with that invalid data? If it genuinely cannot function, what are you going to do with that data? You either clean it up, I suppose, or you throw it away.
It's been when you ban out clean up. So we've got lat logs that are null in the database in some places.
Yeah.
On the planet, or
Well, what do you do with that data? I mean, the question is, what do you do with that data anyway? I mean, you don't put it on the equator at somewhere below Greenwich, do you?
No, but we can't do anything with it at all.
Yeah.
But if we put if it throws an exception which tries to construct it,
Yeah.
we get an exception on the page rather than just say, right, we've got null that long, let's just ditch the map. Yeah.
Well, you could, yeah.
So you end up with quite a lot of.
I mean, I think the question is, are you going to try and clean up that data? Is it valid data anyway? Like, maybe you should just be ignoring it. It kind of depends on the context of that. But yeah, if you had to still have that data, I suppose you can't do that kind of validation. Or maybe you could warn it somewhere. I mean, do you have a team that goes around and cleans up all these ridiculous? I mean, I expect, if it's not breaking anything elsewhere, then maybe there's no point validating it. But the email example, that would clearly break when you're trying to send emails later. So actually, we want to know about it as soon as possible.
It's possible that you could also try using monas, which is always a silly thing to do normally, but rewrite your code so that it expects either an email or null, and then rewrite it so that it handles both cases. But if it's in a legacy code base, you probably don't want to do that either.
Just try and get away from legacy code bases. Anyone else? Yep.
Do you find, because obviously you could put, it depends on the scoping in your own mind of how many of these that you actually put in the code. Every new perspective is a new potential value object.
Yeah.
So for example, your X and Y coordinate thing could be, you could have X and then that could, and Y, and then you could have the point that is both of them, and then it only accepts X and Y. Like, how far do you tend to take that sort of?
You've never got X without Y, would you?
I think in this case, yeah, you probably, because those two live together. So as a concept, it's a point, and a point just requires a latitude and longitude. I mean, maybe if you get 3D, it requires height as well. So I think I would always probably model it on something that has some semblance, some bearing on reality somehow, rather than just, I mean, I know latitude and longitude individually do, but really they act together as a point.
Do you find it, this is much a technical question, but tiring?
I think the more I use them, the more I think.
And then it's like suddenly you've got quite a lot potentially of things.
Yeah, I think the benefits often, not in all cases, but the benefits often outweigh, if it's something you're going to use throughout your code base, like an email, there's a real benefit because you've just got one place where you're validating that email is correct. And I suppose the warning signs for me would be, if I've got some utility method that I'm calling all over the code base and it's all relating to one thing, then actually maybe it's better to create a value object and move the validation to that point. Whereas if there's only a couple of places, or I'm just doing, essentially precondition checks or assertion checks in one place and go, well, maybe I'll just leave that there. So does that kind of answer the question? No. Yeah.
Like, where would you store it in a typical MVC? I don't know what you use for. Do you have it in its own folder called value objects?
I probably store them in a similar place where I would store the model that it's working with. So like the game status thing is part of a game object. So wherever the game object lived, I probably have the game status value object with it because they're very closely related things. So I'd rather have them there than just some random other place. Just.
Have you implemented this for really, really big applications? So if you have an application that's storing thousands of pieces of data per user, for example?
Well, we've done it in things that have got a fair number of points in the database. I mean, we're not talking millions and millions of records. We're talking, I mean, what do you mean by big?
We have 4 or 5 million users, storing several thousand pieces of data per user.
Oh, I see. Well, of all those bits of data, I suppose you've got to look where the value is, because if you've got about 100,000 value objects, I'd probably start with the most valuable ones first.
Yeah.
And I suppose it depends also where where you're using them as well. Like if you're using them throughout the code base, then that would be probably a candidate for one that you want to, to make. Whereas if you're just using it very rarely, then presumably you've got a load of. Well, the first thing I would start would be type hinting if you're not doing that, and then bring in more and more as you see the value. And it's like anything; it's just a tool. Just use it where it gives you benefit over not using it. Yeah.
Are there any libraries on Packagist of like widely used ones that someone's already made for us?
I mean, you certainly get things like I think there are points things. So the lat long example, there will probably be someone on Packagist which has something that represents that. I would imagine there's some email thing as well. Sometimes it's just easy. I mean, I know you shouldn't rewrite your own stuff lots and lots.
But someone might have bundled like 30 or 40 of these things together.
Yeah.
Don't need, you can just use those. Maybe you need a few specific to what you're doing.
I mean, yeah, that is always worth looking. I suppose the other ones, essentially, it's like a language whole, like they don't have enumerations where you've got them in Java, and actually that would work for a lot of these cases, like status objects. Actually, the Java enum is a really powerful thing, and that sort of prevents the need for some of these examples, like the settlement type and the status. You could actually you could exactly do the same thing, but it's at a language level, which is quite nice. Common ones, there must be an email one out there, but if you use filter var, you've got validation of emails anyway. It's almost as long as it took to write on the board to get a good one.
Just a comment from
Yep.
really, but just with valuable objects, of course, the main best practice is they're supposed to be immutable.
Yes.
So just a comment on that really.
Well, that one was immutable.
Value rather than the type.
Yeah. I mean, that particular one was immutable. I mean, you've got to be very careful when you start having things that are composed of other, like other things like even arrays or other objects and stuff like that. Which I didn't want to talk about it in the lightning talk, but yeah, ideally they would be immutable as well. Right, we're going to have a very quick break while we set up.
Thanks very much.
Oh yes, sorry. Yeah, thank you.